Welcome back. So in this lesson we will evaluate our implementation of the random forest. Okay, so here we are, we have the number of estimators 30, the maximum depth is 5, the maximum features is 0.5, and here we are converting this data frame to a NumPy array for xtrain and for xtest, and then we are calling my random forest. This is our implementation for the random forest with the number of estimators, the maximum depth, and the maximum features. So we will create an object of this class, and after that we will fit our random forest with the xtrain and the ytrain, and then we will calculate the accuracy using the OOB score function inside this object. Okay, so let's run the code. As you can see, we have an error here saying name error, name NB is not defined. So this means that NumPy is not defined, right? We didn't really import NumPy. So let's go back and see if we forgot to do so. No, we imported NumPy as NB. So what is the problem here? Let's go back and see what is the problem. Okay, the problem is inside decision tree.py. So it's not in this code. It's in the code for the decision tree, right? So let's open the decision tree.py here. Okay, we have all the functions, but there's a problem here. In order to call these functions, we have here inside this function, for example, we are using NumPy, right? So we are using NumPy.BinaryCount, and we are using NumPy.sum, NumPy.log, and so on. So in order to use this Python script correctly, we need to import all the libraries at the beginning. So we will come here and write import NumPy as NB, and let's save this and try to run it again and see what will happen. We have the same error. Why? Because we need to re-import it, right? But before we do so, let's also import pandas as PD, and we don't really need any more libraries right now. We are not using any other libraries here. So let's run this. And now let's go back and try to see if it will work. So we needed to come here, right, and restart and run all, right? So we need to restart and run the whole notebook again. And here we have an error right now saying maximum depth is not defined. So this is inside the fit function for the decision tree. So we will click here and go to the fit function here, right, and see what is the problem. So we have here maximum depth inside the fit function, right, inside the decision tree script, but we didn't really define the maximum depth in this code, right, in this function. So this function can see only these three variables. Okay, so how we can solve this problem? We can solve it very easily by coming here and changing maximum depth to be self.maximum depth, right? So if we run the code again, you will see that the code is running right now. Okay, so we had some problems and we debugged these problems together. Of course, I knew beforehand that we would have these problems, but I wanted to show you, if you are working on a project and you faced some problems, what are the approaches you use to solve these problems. Okay, so the code of course will take some time to run. So let's get back after it finishes. So I decreased the number of estimators to be 3, increased the maximum depth to be 7, the maximum features to be 0.8, and then as you can see here, current tree to fit, current tree to fit, current tree to fit. So we fit the first tree, the second tree, and the third tree, and then finally the accuracy we got was 0.78. So this is a little bit comparable to the decision tree, right? It's a little bit worse than the decision tree, like 1 or 2% worse than the decision tree, but you need to understand that in order to get better results than the decision tree or faster results than the decision tree, we need to increase the number of estimators. Then the variance will decrease, right? The variance in the dataset will decrease, and so the overfitting chance will also decrease. Okay, we discussed this in a previous lesson in this section. And we cannot really increase the number of estimators that much with our implementation because it's not optimized. We are using loops all over the place, and we said that random forest is actually a bagging algorithm, and we said that bagging is basically training parallel models at the same time. So training the first decision tree on its own, the second decision tree on its own, and so on, right? So the sklearn implementation is much faster because it makes use of the parallel processes, right? So it can make use of your hardware, okay, or the machine's hardware. So each decision tree is running or training on its own, okay, and finally it aggregates the results, and that's it. But we implemented the random forest to understand what do we mean exactly by the random forest, what do we mean exactly by the bagging, and all this, okay? So in the next lesson we will compare our implementation with the sklearn implementation and see if the results are comparable and see how much time it takes to run the code. So let's go to the next lesson.